In a previous video, we looked at the doubling pennies problem, and that was stated as follows: that if on a certain day, on day one, I gave you 1 penny, and on day two, I gave you double that number of pennies, and on the third day, I doubled the previous day, and then added up all the amounts of money that I was giving you, and calling this the amount of money after that number of days, right? This is called the doubling pennies problem. We were asking which option would you rather take? This doubling process added to the previous amount of days, or would you rather take $100,000 per day for 30 days, which would give you $3 million? Which would you prefer? We talked about in class and looked at a previous video that the amount of money that you would have on day 7 would be $1.27. On day 11, you would have $20.47. And to get the amount of money on day 12, you would double the amount of money, which was $10.24 given to you on day 11. I'm going to give you double that amount, or $20.48, on the 12th day. And to get by the end of that day, you will have $20.47 plus $20.48. That means that you have $40.95 total by the end of 12 days. And we went through this process and we continued on and continued on. In the process that you can do for 20 days, you'll have $10,485. And then we showed that in the last several days, right, the amount of money really accelerates quickly. Okay, and then so by the end of 30 days, in this doubling pennies process, you will have $10,737,400. Okay, and if you definitely would want to take that option, that is better. This is better than $100,000 a day for 30 days, which would only give you $3 million. So the doubling pennies problem turned into around $10 million. Now, the interesting question that we looked at in the previous video was this amount of money over 30 days, was that growing exponentially? And we ran the test to look at the ratios of the ratio of two consecutive amounts in the account, and saw that while they're all in the 2 range, they are not the same constant. And the implication of that being that if you were to try to fit the amount of money in the account over this time period with an exponential function from Google Sheets, you would look at this formula that you got. I would plug that in using this formula, right? The same one that I was given in Google Sheets, and then use that formula to say how much do we have at any moment in time. And you can see that while the answers are close, the formula on day 14 is predicting that you'll have $163.32, while the actual amount you'll have is $163.83. Now that's just a difference of about 50 cents, but this is a sign that this formula that we got from Google Sheets does not go exactly through all the data. So the formula looks close, but the fact that these are not constants is saying that there's no formula that will go exponential formula that goes exactly through all this data. The final implication being that if you were to use this formula from Google Sheets and put in 30 days, 30 into that formula, the formula predicts that you'll get $10,850,000, when we know that the exact amount we're going to have is $10,737,000. So the formula predicts that you'll have about, $80,000 more than you'll actually have, which is not a small amount to be off by. Okay, so this is a conclusion of the the growing pennies problem, and a function that we found, an exponential function that closely fits the data but does not exactly fit the amount of money in the account, and therefore predicts the formula mispredicts the amount of money that we're going to have at the end of actual 30 days. So these two numbers compare a little bit differently. So what we want to do in the rest of the videos, another video, is to discuss how does one actually come up with formulas for data that actually is exponential. That is, when the ratio of values, consecutive values, is a constant, how do we go about finding these formulas without having to resort to Google Sheets? That is the subject of the next video.